Hello everyone, my name is Mete Atamel. I am a developer advocate at Google. I'm based in London. And I actually came to Cluj 3 times before. And I was checking Google Photos. When was the last time I was here? I thought it was a couple of years ago, but turns out it was 2018, which makes it 4 years. I think something happened in pandemic where I kind of lost my sense of time, where things are longer. So something that I think that happened last year, it's actually 3 years ago. But anyway, it's great to be back in Cluj. I remember this place with amazing buildings. Like, I don't know, the architecture of the buildings are amazing, and also the food, if you are a meat lover like me, it's great. So I'm glad to be here. And today I want to talk to you about serverless build functions. The presentation is already on speaker deck, so if you want to grab the slides afterwards, feel free to go here. And I'm going to share the link afterwards as well. And if you want to read about this kind of topics, I have a blog and Twitter as well, so feel free to follow me if you wish. And what I mean by serverless beyond functions is that whenever we think about serverless, we think about AWS, Lambda, Google Cloud Functions, Azure Functions, so we are always talking about functions. And actually, serverless is much more than functions nowadays. So the point of this talk is that I want to go through this journey of serverless with you. I want to go through the different stages of serverless that we went through. And the idea is that first I want to tell you how serverless evolved over the years, and also make you realize that all the serverless technologies that's available to you. So that's the point of my talk. And feel free to stop me as we go along and ask questions, because we have plenty of time, and I like this to be interactive if possible. So if you have any questions, raise your hand, and let's hear them as we go along. All right. Serverless, what is it? I don't think I had to explain this in a long way, but just to recap so that we are on the same page, when we are thinking about serverless, we can think of it in 2 different ways. One is the operational model, and this is about how you run your code in a serverless way. And in this model, we usually mean that there's an infrastructure somewhere, but you don't have to manage it yourself. Somebody else does that for you. There is base level security, so you don't have to worry about getting a machine and making sure that the ports are blocked and all that kind of stuff for base level security. It's given, even though you need to implement the other security measures like authentication, authorization. And you also pay for what you use, because traditionally, like in traditional software development, we used to have machines, physical machines or virtual machines, and the idea is that you pay for that no matter what, no matter who uses your service. Whereas in serverless, the service usually is pay for usage model, meaning if people don't use your service, then you don't pay anything. Now, you can also think about serverless in terms of the programming model. So how do you build for serverless? These are usually services, so it's service-based, that are event-driven. So something triggers your service. This can be HTTP, but it can be also events like PubSub messages or cloud storage events. And usually when we think about these services, they're stateless, meaning they have a state, but that state is not within your function or within your container. It's externalized. And the reason for this is that you need to scale up and down in serverless. So if you have this state within your function, then it becomes harder to scale. Whereas if the state is externalized, then you can kind of grab that state as you need it. So this is roughly what I mean by serverless. But of course, in software engineering, everyone have their own definitions. So let's go with this for now. So what are the different phases of serverless that we had? And I think there were 4 distinct phases. The 0th phase, I call it, and I call this like serverless before it was called serverless, because I feel like we've been having serverless for a long time, but we just didn't call it serverless. Then we had simple functions where the term serverless came into the existence. Then we had containers that come into the serverless landscape. And then we also started seeing serverless becoming more mature. And now finally, and this is the phase that we are in right now, we see serverless expanding to everything and also integrating with the existing technologies. So let's go through these phases and see what we had and what we have today. All right, so serverless before it was called serverless. Anyone recognizes this logo? Yes? What is it? Take a guess. You don't remember? but you know the logo. Okay, yeah, the logo kind of sticks to your mind, but basically this is App Engine. And this was launched by Google in 2008. So if you think about it, it's been, what, 12, 14 years? And this is from the original page of App Engine. The goal was to make it easy for developers to build, manage, and scale web applications. And the idea was that you would write some Python code, and you would write a command line tool to deploy the code, and that was it. Like, all of a sudden, you had this web application running. And the key thing here was that you didn't have to provision a server. So you didn't have to call an IT guy and say, I need a server this big, all that kind of stuff. You didn't have to manage a database because App Engine came with data store. And you didn't have to deal with networking. So you didn't have to set up a load balancer and worry about like scaling, all that kind of stuff. So it just worked. But we didn't call it serverless. We called it fully managed service, right? So when we look at this state of this fully managed world, this paved the way and the vision for serverless. It was the first time, at least one of the first times, where people could just deploy their code and see it just working and scaling without having to do all this infrastructure work. But it was very limited in terms of languages and the revisions and then the versions of those languages. So the languages that were supported were Python and Java initially, and even those were like even Python and Java, you couldn't use the whole language. You had to use a subset of those languages. It was only HTTP, so you could only use it for web applications, and that was quite limiting. It was very limited ecosystem, right? It was just Google, so if you trusted Google and say, okay, run my web application, it would work, but that was a big trust that you had to put into a single vendor, and people were scared of that, rightly so. So you had this vendor locking problem where you don't want to put everything you have into one vendor. And at the time, people were running code on virtual machines, and these virtual machines, they were usually on-premise. They were not even in the cloud. So if you go to those people and tell them, forget about your virtual machines, forget about your infrastructure and all the money you put into it, and just move everything to this fully managed App Engine world, that was a big step, right? So there was this VM world, and there was this fully managed world, but there was nothing in the middle to kind of give people a way to move from here to there. And actually, when you look at Google Cloud, I think one of the reasons why Google Cloud came into existence is to kind of fill this middle ground so that people have a way to move from on-prem to the cloud and then to the containers and then to fully managed services. Right, so that was the time before serverless. Then we had this first phase of serverless where we had these simple functions. And this started in 2014 by AWS Lambda. And then it was soon followed by Google Cloud and Azure in 2016. And the idea is that you write a function, deploy, and it just works. And actually, let's just quickly take a look at this just to see how this works. So here I am in Google Cloud. There's a lot of services, but we'll just go to Cloud Functions. And then I have some functions already, but let's just create a function. And we have different generations, but let's go with the second gen, and then let's give this function. By the way, as I mentioned, it's hard to see from the back, but hopefully you get the idea. So this is the second generation, and let's give this function a name, function Workstays Cluj, right? And since we are in Europe, let's choose something in Europe. And then let's make it public. Next. And then you have this runtime, where you have these different languages and different versions, and some of them are in preview, so on and so forth. But since this is a Java conference, let's choose Java 17. Then there's some boilerplate hello world code, and we hit deploy. And that's it. Like now the function is being provisioned, and it will be deployed. And as that's being deployed, we can look at other functions that I have. I already have this function that I deployed, I think, today. So if we click on it, we see that the function is running. We have this dashboard. We have this link. Click, and then it will just say this exciting message, hello world, right? Nothing complicated. But the point is that it's so easy now to go from your code to a running function in the cloud where you don't have to worry about the infrastructure and you don't have to worry about scaling this function. It's done for you. All right, but you need to keep track of this table in your head. What I mean by this is that, depending on where you are, let's say you're on AWS Lambda, and depending on the language that you have, let's say Java, then you need to go to the documentation and see, okay, is Java 11 supported, Java 17 supported? And this table is probably already out of date because I made this 2 months ago. So it's constantly changing, and more runtimes are being added, but you still need to think about this. It's not like you can take any function and deploy whatever code you want. It needs to kind of fall into one of these runtimes, and that's quite limiting. And when you look at your functions, initially at this phase, in first generation of Cloud Functions, for example, it was mostly HTTP driven, so HTTP triggers your function. And then there was also a handful of triggers. For example, you could have cloud storage triggers where someone can save a file and that triggers an event and that event goes to your function. Or you can have a PubSub trigger where you have a queue and then you can send a message to the queue and then that gets pushed to your function. But it was very limited. It was mainly HTTP driven and it was only a handful of services that can trigger your function. So it was quite limited in that sense. And then when you look at the execution model, time and resources that you have with these functions, again, with generation 1, it has to be HTTP based, so you need to talk HTTP. And you need to, by default, respond within 1 minute. So when you get a request, you need to respond in 1 minute. You can increase that to 9 or 10 minutes, but it's still quite limiting, right? So you can't do batch processing, for example, where you have lots of data and you can run it for hours or days or weeks. You can't do that. It's limited. Similarly, the CPU and the memory you get is very limited. 8 gigs of memory and 2 virtual CPUs, meaning you can't run anything like anything that requires GPU, for example. So you have to also keep this in mind as well. And we also had this cold start problem. So in Cloud Functions Gen 1 again, and by the way, I'm giving most of my examples from Google Cloud because that's what I know, but most of these problems, they also existed in other services. So I'm just, my examples are mostly cloud-based, Google Cloud-based because that's what I know. But these problems, they did exist in other places as well. And this cold start problem happened because the concurrency was 1, meaning when a request came in, you had to create a new function to handle that request. And there was no minimal instances setting, meaning you couldn't get these functions running in the background waiting for requests. So that means that anytime someone makes a request, you had to pay for this penalty, basically, for latency, so that you can respond back to the user. And users actually recognize this as latency in their applications. And then once you have a lot of functions, then you need to have a way to group them. And actually, on AWS, there was no way to have a public function until you deployed an API gateway. So that's why they started supporting API gateway pretty early on. Whereas on Google Cloud and Azure, you could have public functions, so that's why you didn't really need an API gateway. But that's okay for one function, but one function can handle one path. Usually when you're building an API, you need to handle multiple paths. So that means that to build an API, you actually need an API gateway so that you can kind of have all these paths combined together at the API gateway level, and then you can send the right path requests, the right request for the path to the right function. So there was a little bit of grouping for HTTP functions using these API gateways, but that was it really. That's all you could do in terms of groupings. All right, so the state of serverless at this stage was, we were limited with languages and revisions. We were limited with triggers, mostly HTTP based. We were limited with execution model time and resources, so we had to think about what we can run on the function. There was this cold start problem. Then I didn't mention this, but the local development was also quite limiting. So you had to actually deploy a function to see it running in the cloud and test it. And we had some grouping for HTTP-based functions, but there was no complicated orchestration or anything like that. So even though it was a good start, it was quite limiting. So you couldn't run anything you want the way you want. All right. Then in the next phase, we started seeing containers come into the picture, and we also started seeing serverless maturing more. But before I continue, any questions so far? No? It's OK? All right. All right, so well, for a while, we had this kind of world when it comes to serverless. We had these functions that do limited things, but if you could use them, it was great because you have velocity to iterate because you don't have to worry about the infrastructure. But if you couldn't use that function runtime for whatever reason, then you were on your own. You had to kind of figure out how to deploy your code, how to run it, how to scale it. And what most people did is that they either run their stuff on virtual machines, but mostly they run their stuff in containers. Then all of a sudden, you need to worry about your container, how to create the container, how to deploy the container, how to scale it. And then there were projects like Kubernetes and Knative that made this a little bit easier, but not so much easier. Now you need to learn about Kubernetes, the terminology of Kubernetes, all the complexity of Kubernetes. So these containers gave you the flexibility because you could create the runtime that you need with the language you want, with the libraries you want, all that kind of stuff. But you lost the convenience of serverless. And this was the world for a while. Thankfully, there are technologies like Cloud Run on Google Cloud, and Fargate and AWS Lambda even runs containers nowadays. And on Azure, there's container instances. These technologies, they're quite different, but they all try to do similar things in the sense that they try to give you a way to run containers as if they're serverless functions, basically. And if you look at Cloud Run on Google Cloud, it's actually based on Knative. And actually, the previous speaker, if you were here, she talked about Knative. Knative, it's an open source technology that enables you to run containers on Kubernetes. And then there's a managed version of that on Google Cloud called Cloud Run that lets you run containers and not even care about a cluster. You just say, this is my container, and let's just run it, and that's it. And actually, let me show you this as well, since we are here. So if I go back to Google Cloud Console, now I have my function, and now I want to deploy a container. So I go to Cloud Run, and let's say I want to create a new service, and then here, you can choose what container image you want to deploy. So usually, you would build your container. You would push your container to a container registry. But here, let's just use a test container for demo. So I choose that. That's already there. And then I call this name. Let's call it Hello Workspace Cluj. And then region, again, let's choose something in Europe, West. And then there's other options that you can set, but let's just keep them the same. And I need to choose something else. Let's see what I missed. Oh yeah, I want to make it public, create. And now a service is being created, and now the container is going to be deployed, and within a few seconds, well, a minute or so, you will have a service running that runs your container. And actually, it's already running. So if we click on it, we'll see this. It's running. So it's so easy. Now you can run containers as if it's serverless, basically. Like I didn't provision machines, or I didn't have to worry about Kubernetes cluster or anything like that. But you cannot run any container. These containers, they have to kind of adhere to a contract. And this comes from Knative, actually. So the container has to listen on port 000 and port environment variable. This defaults to 8080. And then your HTTP server has to start within 4 minutes, so it has to start quickly. You can respond to requests within 5 minutes, but you can increase it up to 60 minutes. So now you can do a little bit longer processing with containers rather than 10 minutes with functions. Your containers has to be stateless for scaling again. And you can only do computation within the request, so you cannot do background processes, stuff like that. Now you have more resources, so you can go up to 4 CPU and 16 gig. And then you have more concurrency that I'm going to talk about in the next slide. And you also have ability to listen multiple paths. So since this is a container with a web server, you can listen multiple paths, meaning you don't need an API gateway to do an API. You can just simply run a container if you wish. So as you see, things are getting better in the sense that they are becoming more flexible, and we have more kind of memory and CPU to do things. And also, concurrency now is not 1 anymore. If you look at Cloud Run and also Cloud Functions Generation 2, concurrency is 80 by default, meaning a single container or function can handle 80 requests at the same time. And that helps for cold start problem, because now when a request comes in, it's more likely that your container is already running and handling other requests. And because of that, you don't have to create a new container for every single request. And also, this second generation and Cloud Run, they also added this minimal instances value, where you can just say, my minimal instances is 5, and that means you will have 5 containers running at all times, and that also helps for cold start problem. So cold start is not a big problem anymore because of concurrency and minimal instances. And the local development is getting better at this stage. Since we are running containers, we have the container ecosystem with Docker and all the container tools that help you to build locally and run locally. There's an open source project called BuildPacks that lets you go from your code to a container without having to write the Docker file. Because one of the things about writing Docker files is that it's very hard to do correctly. I mean, you can get a hello world Docker file pretty easily, but if you need to make it efficient and also secure, there's a lot of things that you need to do right, and it's not easy to do, in my opinion. And BuildPacks help for that. So it looks at your project and your code, and it figures out what language you're using, and it tries to kind of build the right type of image for you, so you don't have to worry about it yourself. Then there's projects like Functions Framework that lets you run Google Cloud Functions locally. There's emulators for different services that you can use to emulate in your testing. And then on AWS, there's a project called Local Stack as well that lets you basically to do your stack locally so that you can do testing. So things are getting better in local development space as well. And I think I talked about this, but basically you have more time for requests, more memory, and for me, the biggest addition at this stage is the richer protocols. So far, we've been mostly talking about HTTP-based services, right? But with Cloud Run, you can actually have WebSockets for real-time connectivity. You can have gRPC for efficient encoding, so what goes over the wire is more efficient. And you can also have server-send events. So all of this enables more real-time kind of applications. So it's not just a simple HTTP and a response anymore. And then we also started seeing some basic orchestration at this stage. So if you want to, for example, schedule a call to your function or a container at a certain time, you can use Cloud Scheduler, and you can do this fully serverlessly, so you don't have to worry about machines. And by the way, Cloud Scheduler on AWS is CloudWatch, on Azure is Scheduler. Or if you want to have a task-based system where a user does something and you create a task, you push the task to a queue, and that task gets pushed to your service or container, you can use Cloud Tasks or SQS or Service Bus on Azure. So these are simple orchestration tools that helps you not just run your code, but also have some logic around it so that they're called on a certain time or in a certain way. All right, so what's the state at this state of serverless? Now, with containers, you can pretty much run any language and version. Of course, the container has to adhere to a contract, but at least you can use the language that you want. You're not limited by the runtime of the function. Your triggers are still limited, so mostly HTTP-based triggers and a handful triggers, but nothing, you can't connect anything to anything yet at this state. The execution model, time and resources, they're improving. There are still limits, but you can do much more than just a simple function. Cold start is not a problem anymore. Local development is mostly OK, because you have containers and tools locally that you can use. And we have some grouping before with API gateways, but we also have basic orchestration with schedulers and tasks and things like that. So things are getting better, but not like perfect yet. And it's not going to be perfect, of course, but we'll see. All right, so in the last phase of serverless that I think we are in today, we started seeing expansion of serverless to pretty much everything, and also integration of serverless with existing legacy technologies. So let's look at what we have here. All right, so once you start having a lot of services, whether they're function-based or container-based, at some point you need to kind of figure out how are these functions or how are these services going to communicate and cooperate, right? And there's a few options. The easy option is to have each service call the next service directly. So you have service A calling service B, and then service B calling service C. I don't show it here because I don't think it's a good model, because it creates a lot of coupling between your services that you need to keep track of. You need to keep track of who is calling what service, and also you need to keep track of, let's say you want to change service B, then all of a sudden you need to think about service A and service C as well, because there's all these dependencies. So that's not a good model. What you can do is you can use events as an indirect way of communication. So in this case, actually this diagram is a little bit misleading. It shows you as if service A is sending events directly to the service B. It doesn't work that way. What you have is usually a message broker or a message bus in the middle, and you configure which service is interested in what kind of events. And then when service A does its work, it will just emit a message, let's say message event type A, and then it will go to the message broker. Then message broker will look at that and say, okay, this event, service B is interested in this event A, and it will route that message to service B, and then service B will do its work, and it will emit its message, and so on and so forth. And the advantage of this event-driven, also known as choreography model, is that your services are loosely coupled. They don't know about each other, they don't care about each other, they just communicate indirectly via events. On the other hand, since you have this loose coupling, and since you have all these different event types flying around, it becomes difficult to monitor when something goes wrong. So let's say you run your services, and then in the end something doesn't work. Then it's not immediately obvious where things fail. So what you usually need to do is you need to look at your services, look at their message queues, see which services message queue is backing up, maybe check the logs, and then from there maybe you can figure out what's wrong. But you don't immediately see that, okay, service B failed. So that's the problem with event-driven systems. Another thing you can do is you can use an orchestrator. An orchestrator it's an external service where you define how things should be called. So on Google Cloud, there's something called workflows, for example. In here, you would define, I want to call service A, and then service B, and service C, and service D. And you also define what should be the inputs to these services and how should you capture the output. And then this orchestrator will do these calls on your behalf. And the advantage of this model is that now you have this central place for your architecture, so you can basically look at here and see how things should work. And also, let's say service B is down, it will be really easy to see that because workflows will make the call to service B, it will fail, so you will immediately know which step failed and go to that service in that step. So it makes it easier to keep track of things. So if you want to do choreography or event-driven systems, so that there are technologies like EventArc on Google Cloud that lets you connect different sources to different destinations, basically. And then there's PubSub for low-level messaging for message queues and topics and subscribers and consumers. And of course, on AWS, there's EventBridge, Azure, there's EventGrid. So they all have similar names with similar technologies with slight differences, but they all try to do the same thing, basically. And when we look at EventArc, what it basically does is that it gives you now a lot of different triggers. Now, all of a sudden, instead of having just HTTP-based triggers, you have all these Google Cloud sources, hundreds of them, or even third-party sources from other providers becoming triggers for your service. So you have a lot of services now that can trigger your service using EventArc, And not just your function or Cloud Run, but also your orchestrations or even Kubernetes services as well. So now you can pretty much connect any source to any destination using these kind of technologies in the middle. And if you want to use an orchestration, let's say you have this kind of flow, like where you kind of talk to a database, you check if something is in stock or out of stock, and then you do certain things by calling a third-party APIs. You can use workflows on Google Cloud. On AWS, there's step functions. On Azure, there's durable functions and logic apps. Again, they all try to kind of orchestrate how your services should be called. And if you look into workflows a little bit, it basically tries to orchestrate and integrate your code running in the cloud, other APIs that you can call from your code, and even external APIs. So anything you want to call externally, you can include in your orchestration, and workflows will make sure that whatever you define just runs in the order that you define, and it lets you know if something is wrong. And let's look at this example quickly. It's a service chaining example. So let's say you have service A, B, C, D, and you want to call them in that order, but you want to have an orchestration call that for you. So you want workflows to call that for you. How can you do that? Well, first, you need to deploy your functions or containers. In this case, I'm deploying a cloud function. It's a Python function that creates a random number. So it's a random number generator. Then I deploy another function called multiply that takes a number and multiplies it with another number. So it's two cloud functions. Then I have this external function from math.js. So this is an external math library that you can call that I will use to take the log of the number. So you give a number and it gives you the log of that number. And then finally, I have this fourth service running on Cloud Run. So it's a container that takes the floor of a number. So you pass in, say, 6.5, and it returns you 6, basically. So as you see, here I have two functions, one external service and one container. And I want to bring them together into an orchestration. How can you do that? Well, you need to define your orchestration. So you do that with either YAML or JSON in workflows. And in here, you define steps. So the first step is I call it random gen function. So I'm basically making a get request to my cloud function. So this will be done by workflows. And then the result will be saved here in this random gen result variable. Then I call the multiply function. And this is also a cloud function. And the input will be the result from the previous step. So we capture this result and we pass in to the next function, right? And this is done by workflows. Once that's done, I want to call my third service, this time math.js. And here I'm calling math.js with the expression log. And then I pass in the result from the previous step. And finally, in the last step, I call my Cloud Run, which is a container. And this time, I am passing the result from the previous step, but I'm also passing an authentication token because it's a private service. And this is how you can authenticate with workflows with that service. So as you see, two public functions, one external function, one private container, and I just bring them together. And in the end, we just return the result. And just to see that this works, I can go to workflows. And let's see, service chaining. So I already have it here. So you see that I ran it before, but if you look at the source, you see my source here. And also, I also like this visualization where it tells me, okay, this is how your things should work. So you can see how things should be, like what's the order of the calls. And then to execute it, you can execute from API, but here I'm just going to execute from here. And I don't need to pass anything in, I'll just no input execute. And now workflows is calling random gen, multiply function, floor function, and then floor is calling external function, and then finally return result. In the end, the result is just a number that was generated and applied some transformations. But yeah, you see how this kind of stuff works. So that's the idea of workflows. All right, and so once you have the orchestration, what I also seen is that people combine orchestrations with event-driven architectures to have the best of both worlds. For example, I have this sample application. It's already on GitHub if you want to look at the details, where the user saves an image to a bucket, and then that kicks off some functions and processes that image. So the first function, it's a filter function that checks if the image is safe using machine learning. Then the second one is a labeler function that extracts the labels out of these extracts the labels out of the image, so using machine learning again. Then the next one is a resizer function that takes the image and resizes the image. And finally, there's the fourth function, the watermarker, that takes the resized image and also the labels and creates a new image with the labels on top and saves to the output bucket. So these 4 functions, they need to be deployed together, and they also need to be called in this order, right? Because of that, it makes perfect sense to put them into an orchestration. So that's why I created an orchestration for this using workflows. But then, how do you trigger this orchestration? This is done via an event. So when a user saves an image, that will trigger an event using event arc, and that event arc will send that event to workflows, and then that will do the orchestration. So here, the things that make sense together, you put them into an orchestration, but you trigger it in a loosely coupled way because you don't need to create this one-to-one dependency between the user doing something and calling your orchestration. And actually, let's take a look at this one too, just quickly. So I think, let me see if I have it here. Just to show you quickly how to set something like this. Well, first what you need to do is you need to deploy your services. So I deploy my watermarker service, which is a function, the resizer, another function, labeler, another function, and the filter, another function. So they're deployed. We don't have to worry about them. But the key is to define an orchestration for these functions. So the orchestration is defined in workflow.yaml. It will receive an event from event arc. So once we receive an event, this is a file event. We will log the event, and we will extract the file information, the bucket and the file of the event. Then we make calls to our functions. So the filter function, we make an HTTP post call. Then we get a result and check if the result has safe in it. If it's safe, then we know that it's a safe image. If not, we will end the orchestration. So you can do a little bit of logic within your orchestration without having to do this in code. Then if everything is good, we will call the label function. Then we'll call the resize function to resize the image. And finally, the watermarker will be called with the image from resize function and then the labels from the label function. So that's how you would make that call. And then the final result is just HTTP code from all these functions just to see that they all return correctly, right? So this is how you define your workflow. And then you need to connect this workflow to events. And for that, we are creating an event arc trigger. So this trigger basically says anything you save in this bucket as a new file, so this is object finalize event. So if someone saves a file into this bucket, then send it to this orchestration. So send that event to this orchestration, and that will trigger the orchestration. And just to show you that it works, if we go back to workflows, I think I have this. Let me double check. Image, yeah, image processing and source. And again, it's really helpful to see the how things should work. So we check safety, for example, and if it's not safe, then we see that we'll just go to end. So the orchestration is here, and then actually, let's just check the trigger as well. So if I look at my event arc triggers, I should see, yeah, I see that there's a trigger called image processing, and it's a cloud storage trigger, and it's going to call this workflow. So if something happens, it will call this workflow, and event type is object finalize. So that's also set. So let's trigger this by sending an image. So we'll just save an image to a bucket. So this is the input folder, and I'm going to just upload an image. Let's see, I have some pictures. So let's upload this picture, for example. So now all right, so I'm uploading the picture to the storage bucket. That will trigger an event. That event will go to the orchestration, and orchestration will do all the work. And then if we look at the output bucket, if it's finished, well, it's loading. The internet is a little bit flaky. Maybe I do a refresh. But basically, I mean, if this doesn't load, I'll show you later maybe. This will process the image and just save it here with the labels and watermarked image and resized image. But I'm not sure why this is not working right now. Let's go back. I'll try one more time and then we'll move on. Okay, yeah. So it's here. And so if I look at this picture, for example, yeah, you see that this is the image, and then it says water, cloud, sky. These labels were picked up by machine learning, and then it was resized image, and then it was put on top of the image. So you see how that works. Okay. And another thing I see quite often nowadays is combining what you have with servers and using serverless orchestration to orchestrate them. This is useful when you cannot use serverless. Let's say you want to run a long-running process where you want to calculate something for a long time, or you want to process some data for a long time. In that case, you cannot use serverless really, because all these technologies, they have limitations on how long they can run. They can run maybe up to 1 hour right now on Google Cloud, maybe 1 day. But let's say you want to run something continuous, or you want to run something for a week. What do? Or let's say you need a GPU to do something complicated. You don't have GPUs on these functions, right? But what you could do is that you could get a VM, virtual machine, with the configuration that you need, with GPU and everything, and then you can orchestrate, use workflows to manage the life cycle of that VM. And the idea here is that you don't use serverless directly. You have servers, but you're using serverless to manage it, and that way it's almost serverless, right? So you don't have to worry about the VMs yourself. And I have this example to show you how to run a long-running container for a long time using on a VM, but have workflows manage that. And actually, let me show you quickly how that looks like. So here, for example, I'm doing a prime number generation where you just run your orchestration. It creates a virtual machine. Let's look at it. So you run your orchestration. It creates and starts a virtual machine by calling the Compute Engine API. And then it will wait for the VM to come online. Then it will start the work on the VM by calling an API. And then it will wait however seconds you want. So if you can wait for like up to 1 year on workflows, by the way. So you can wait up to 1 year and let this run. And then once it's done, you stop the work, and then you delete the VM, and then you just return the result from the VM, right? So in this case, you are basically almost serverless in the sense that the VM creation happens, but you don't have to kind of worry about that yourself. And if I just show you one, I'm not going to execute it now, but I'll show you the execution. So if we go back to workflows, prime generator. So for example, I ran this earlier, and all I did was basically, I just say, okay, execute this. I want to give my instance a name. So this is a VM name, and I want to run it for 60 seconds, so 1 minute. So I just pass that as input, and then the output I get is a number. It's a prime number that it calculated. And that's it. So as a user, I am almost dealing with serverless, where behind the scenes, it's a virtual machine that runs and gives me the result. So this pattern can help you for things that you need to maintain that are on VMs, but you can make it easier for you by using some orchestration around it. All right, and then last thing that I want to mention is there's also work that's happening for non-HTTP containers. So let's say you have some code, you just want to run it, and that's it, run to completion. Or maybe you have some data, and you want to run on multiple containers, process the data in parallel. There's something called Cloud Run Jobs that enables you to do that, basically. It enables you to run multiple containers in parallel and just run to completion without needing to do HTTP requests. So you don't need to start something or stop something, it just runs, processes, and finishes. And again, it's the same pattern here. You can use Cloud Run Jobs to do the job, but you can use workflows to manage that, to manage how these are created, how they are run, and how they shut down. And I have a couple of examples here if you want to look at later the details. All right, so where are we now after all this stuff? Now you can run any language and version with containers. You can connect almost any source to any kind of service, so you have rich triggers. We have much more improved execution model times and resources, so you can use Cloud Run up to 1 hour, but if it's not enough, you can use a virtual machine and manage it in a serverless way. Cold start is not a problem. Local development is usually okay because you're running usual containers and you can run those locally as well. And we have grouping with API gateways, but we also have this rich orchestration options with event arc and workflows and logic apps and all the stuff around serverless. And we didn't even talk about data part yet, and I won't talk about it, don't worry, because we're almost out of time. But basically, all the stuff that I talked about is about how you run your code in a serverless way. But once you figure that out, it's good also to think about data. Like, if you're using NoSQL, for example, there is serverless options like Firestore or DynamoDB, where you don't really need to set up and run these yourself. You can just create and it just works and you just store what you need to store. Or if you want to use caching, there's like memory store, elastic cache that are almost serverless. Or if you just want to do like send an email or make a call or SMS, there are services that are not serverless per se, but they help you to do these things without having to think about machines. So whenever you're building something, I guess my whole point is that whenever you're building something, and especially if you're in the cloud, make sure you check your serverless options first and see if it will work for you. If it does, it will save you a lot of hassle of management. If it doesn't, then you can also see how you can use serverless in orchestrating things that are not serverless. So either way, I think serverless has something to offer if you are in the cloud. And I think that's it. That's all I have. So thanks a lot for listening. If you want to get the slides, here's the link. And if you want to reach out to me after today, this is my Twitter. And we have some time, so if you have any questions, I'll be happy to answer any questions that you might have. Thank you.